Okay, we're back online again, and we'll carry on for what we have started this morning. Yeah, so with the flow of current, that's what we have left before we go to break. So yeah, that one is fully understood. So now, overcurrent grading. Overcurrent grading. So protection operation must be selective and only isolate the faulted item of a primary plant or whatever is that. So this ensures continuity of supply to the remaining transformer. Like for example, if you have fault on CBC, don't expect to trip the incomer. It will affect other areas that is not affected by the fault. So by doing that, you have to do some kind of curve coordination. The curve that we discussed earlier, that will be plotted to each other in the design. This curve will trip longer on this amount of fault. And this amount of fault, this one will be tripped quicker. This is slower than this one. This is slower than this one, so that you can isolate only a specific breaker which is affected by the fault. So that's how it works. That's how important the trip time is. So overcurrent grading. So fault current levels are greatest closest to the source. They are determined by the source of network and impedances. So the higher the fault will be, the closer to the source. So if this is your source, how many MVA, 1.5 MVA or 2.5 MVA, the common one, the closest breaker there, which is the incomer, should be the highest fault as expected. As you go farther down the line, the fault will be a little bit smaller because you are farther than the source. So that's why the settings of instantaneous trip is this one. For this magnitude of current, will be quicker on this one. Of course, this is only half of this. So it will be slower than 50% probably, depending on how they design the grading of tripping. So if you look at the curve, that's the curve. So overcurrent IDMT characteristic or inverse definite minimum time characteristic, commonly used. So you are looking at magnitude here, and you are looking at the time here. So as you go farther, which is higher magnitude, you go quicker. But if you go here, below that specific trip setting, almost no trip. But once you hit that curve over there, let's say 10 seconds, somewhere here, just picking up. But if you go higher magnitude, it go quicker. Here is probably 0.1 or 0.12 probably, 0.12 seconds. So current setting determines the minimum operating current. Time multiplier determines the operating time. That's what we discussed earlier. Characteristic types determine the curve or shape. So that will be tracked by our relay in terms of response for the trip contact to react on that abnormal current. So if you look at that one, the discrimination, as what I discussed, I mentioned earlier. If you look at this one here, with this 100, you are quicker, which is that one here. I go down a little bit. So 1000. This is 1000, the red one. If you look at the trip time of 3, so this is quicker, which is the first one. And this is a bit slower. The time is almost 1 second. And this incomer, which is A, is more slower than the 2. So if you have some kind of fault level like this, you expect that these two will not trip. That's how they design the curve coordination of the tree protection. So if you go higher, so that one is 2,500. Here, of course, that one will go This one will trip first before this one. This one will not be affected if your fault is here, because the CT of this is blind to this fault. Your CT for the CB is here. So the CT of this will pick up and feed that one, but this one will not be affected. So as you go on, so that's how the determination of the trip is depending on the location of the CT as well, because that's the only thing that will feed your relay. Now that's 4001 is the 4000, which is this one here. It will trip quicker because of the fault level, and these two will not trip because the fault happened on this. We don't know how many kilometers is this, but normally this CT will pick up the problem going downstream, being an open zone protection. So overcurrent definite time characteristic. So it common use to speed up the protection, which is no need for the curve. It's always instantaneous. Also use the fixed predefined operating time is required, such as sensitive earth fault. Again, it's a closed zone, which is no need for the curve. It's always instantaneous to protect the system. So current setting determines the minimum operating current. Time settings determines the operating time. So there you are. So discrimination of IDMT. If you look at this area here, that is a definite time already. That square over there, instantaneous. So here you have curve depending on the time will vary depending on the magnitude of the current. But here, if that one comes here in this area, this speed of time like 0.12 or 0.13 will take over. And if you go here, if this fault is somewhere here, it will be quicker, probably 70 milliseconds, which is quicker because of the fault level is higher. So we need to test that when it comes to protection relay testing, and we need to simulate, or the purpose of our protection relay test sets is to simulate the behavior of the fault. Like for example, if I want to do this one here, I have to simulate that on the secondary I can inject at that level. So you have to understand the fault in order for you to make the test sets to function as what you want to do, how you understand the settings of the relay. So understanding the test sets, understanding the software of the relay is very important, and understanding the schematic. So all are just consolidated. So same, if you go there, higher level, the quicker time is expected to trip. Now, hands-on protection relay testing. So you need to do visual of the board. What is the condition of the relay? It has existing trip. Take photo or get information. What is the condition of the breaker? Is it isolated? Make sure that the proper isolation is done. Test for dead. Everything should be done first before touching it. Check the schematic drawing. Identify the CT again, VT connections, and relay trip output contact, etc. So communicate to the relay under test, or communicate to the relay test sets. So that's very important. And so create test plan based on the following. You cannot create test plan without extracting the actual settings of the relay, what is inside of the relay. So you have to extract those. What is the top setting? What is the trip time? What is the curve being used? Normally inverse or very inverse. That's very vital for you to create the test plan. So actual analog inputs or three-phase voltage, you have to check that if there is a voltage input or no. If there is, definitely there is a CT, but sometimes BT is not available for some simple feeder. So three-phase secondary current, of course, you have to identify those. And also the trip alarms, contact, which is can be found in the manual anyway and the drawing. I/O outputs, which one was being used. And also reference documents will be schematic drawings. It's the best one to have the schematic drawings. and relay manuals. And I think that's it for now, but we have to proceed to how to create the test plan. So bear with me. So like for example, let's say that I already connected to the relay. I managed to talk to the relay, blah, blah, blah. So anyway, I'll find, if I can find the last one that I did in South Flank. No, that's not the one. Where is that other one?
That's a big laptop.
That's an example.
Yeah.
Probably this one, eh?
Did you transfer the file onto Nick's laptop?
Yeah, I think so. Yeah, this
Is
one.
it on a USB?
Yeah, in the USB.
Alright, so goes to open, you'll have to go onto the USB.
I think this is the one. Yeah, so start with 3. I think this is the one that we did, David.
Yep.
So normally we extract that one, we get the serial number, the version and everything, make sure that we have everything, and you have to go to the system. Normally we have to find out what is the CT ratio. You have to consider that as well. So we need that one. So you have ground, just a sensitive earth fault of 100, phase CT primary 150 both, and you go here on, that's the auxiliary in a way for the relays, trip close, and you have to go here in the phase current. You have to check that, click that one. So now you have the overcurrent setting of 0.7 of the CT. That's your tap. And you have the curve of IEC, curve C. And you have your multiplier of 4, or TMS, or time delay. So your instantaneous, you have 5.37 times CT, and the trip time is 0.45. So we need that. We have to keep those information. Bear with me. Okay, and the other one, I think there's another level. So you have the stage 2 of your instantaneous trip, which is, if you notice, it's more quicker. The time is 0 seconds and 20 times the CT. So it means on the primary, 20 times 150. So that's a huge fault current. And this time is quicker than this, first stage and second stage. And if you look at this one, disable, no need for that. Disable, no need for that. Let's see the ground over current. Yeah, trip, so we have to keep that one. Those components is required for us to create a proper test plan. What else? Ground, disable, ground instantaneous, directional, disable. I think that's it. There's no neutral, it's disabled as well. So normally we check one by one so that we avoid missing some of the activated protection. Okay, I think that's it. Negative sequence. In my memory, there's nothing there. Of course, we'll check the voltage. Sensitive earth fault. Let's check this one. Disable. 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 Restricted. disable. We'll check the voltage, if there's some voltage protection. Yeah, disable. Over voltage, normally over voltage, disable anyway. Frequency, under frequency, so you have under frequency trip, which is 48.8 Hertz. So those are the functions that we need to deal. The second stage is off. So once you have that one, normally we save as found settings for us to record everything. And sometimes I use that one, and sometimes I write it on my note. I don't know, I always write in my note. It depends if how you are comfortable anyway. Test universe. So we go to test universe. I wish I could have two screens to show you, but anyway. So once you open that one, you make sure that you are connected your communication. Yeah, this time I think it will not show anything because it couldn't detect the equipment. We don't have that one here. So that's fine. You have to start there to talk to the device first. Your laptop will be connected to Omicron. And you have some kind of modules here, controller, ghost messaging whenever. We will not do that one because that one is a little bit high end. And this one here is doing basic relay. So you have some choices. You can go quick CMC, pulse ramping, state sequencer. And if you want to do proper test plan, or if you have already saved test plan, you can open the existing test document. Or, like for example, for today, we're gonna do new test plan. So there you go. So I want to see those, but anyway. Minimize this one. Let's see if we can both run it together.
Even you can close all the universe.
This one?
Yeah, you can close it.
This one? Yeah. So before you start, I think sometimes for me to remember some things, I need to do some kind of acronym. If you remember the unit of resistance, it's ohms. So ohms means I can apply it here. I will start the test object as letter O. So I click the test object as Ohm's law OHM. So we are on O. We have to fill that. So you have to fill that, like for example, overcurrent, where we are talking about the test object. So overcurrent,
Double click device.
the device.
Yeah.
So for that one, we have to fill out first the information of the relay, like for example, name of description, stacker 3, probably.
Or the name on the panel.
Yeah,
It's up to you how
it's up to you.
how you remember that when you're doing a report now.
So manufacturer, so you do G, device type, yeah, so feeder, address, serial number, it's everything there. Probably let's do some kind of random. And also here, you have to check this. Sometimes if that one is 60, sometimes it will create problem in your test results. So this time, let's say 6.6. Secondary, isn't it?
Yeah.
110 probably. Yeah, 63.5. So the primary, let's say 6.6 kb. So it's automatically computed line to neutral. So your primary nominal is that, KA,
Let's put it as MV.
MB should be K. Yeah, KB. So secondary and primary 150, is it?
Yeah.
Move the thing. 150 amp is to 1. So you have that one, and drop out time, probably leave that way. Limit, you don't want to cook your relay if you mistake, so you can leave it that probably 200 is alright. Instantaneous, I would say too big. I would say 30 or 25 amps probably maximum. So debound, so leave that one. So if you have that one, okay. So we go back to the Ohm's law. So O means object, we add the object. So relay parameters, we use non-directional. We leave the thing there, and we go to element. So when it comes to element, we have to choose the curve. For this specific, there's a drop-down selection in a way, but we need to select the phase element. So curve C. So curve C in my memory is that extremely, I think.
Yeah.
Extremely inverse. So we select that one. That's it. And this formula, there's a constant as what we discussed before. Everything is there, so select that. So there you go. You have this. And you have to use your tap. What is the tap that we have? Go back here. 0.7. So 0.7. So every information will be coming from the relay. Time index means time multiplier or time delay, TMS. So 4. So we put 4 over there, and it will change everything. Oops. Yeah, moves a little bit. And view the results. So that's your curve. So if you add another one, let's go back here. So that is your curve using this one. But if you want to see a complete curve, including this phase instantaneous, you have to add that one as well. So you have to add another one. I would say this is yeah. So phase time over current, or I would say that one there. And this one probably phase instantaneous. Stage, and we have to select again this here because that one is instantaneous. Definite time.
On the top one?
This one here. So that's the thing. Definite time. That's what we discussed earlier. So select that one. And of course you have this peak up here. So I reference will be what? That's 5.37. And your time, what's the time? 0.45.
450 milliseconds.
Yeah, 450 milliseconds. So there you go. Let's have a look. That's how it looks like. So the first state of short circuit quicker than your curve. So we have to add another one because for this specific relay you have a stage 2, which is severe short circuit. So you had another one. Okay, depends how you put this on this label, because this one will reflect in your report. So put that one, definite time again, and we see there 20, and this is 0. Sometimes I never put 0. I would say 20 milliseconds sometimes. But we can put 0 anyway, just for this one. Okay. So see, if you put 0, it just goes straight, dead, flat, So this is your severe second stage short circuit. So now you've done that one, you set up everything. So you click OK. So you are O. So remember Ohm's law, object. So OK that one. Now Ohm's law, there's H. You set up the hardware. So for this one, you need to select a specific. So we don't need that combination. We only need. There's a voltage, of course. We want voltage. So 3-phase neutral will be all right. And this one, we can select probably this one here, 3-phase. So that's what we want, isn't it? Based on the drawing and the schematic that we have, sometimes we remove this because sometimes there is no voltage protection like frequency or over under. Since we have frequency, we need this voltage. And 3-phase current, 3-phase voltage, that will do the work, isn't it? So you have to analyze everything based on the documents available to you.
Yeah, I always use 3-phase voltage and current for mine because as part of our test, we need to verify also the metering.
Metering, yeah.
Yeah. It's not only just jump to testing because in doing metering tests, we confirm that our wiring setup is correct. So that's our first check of our after we complete our connections. Yeah.
Okay.
Check. Yeah.
That's a good one, Janelle. Thanks for that. And okay. So analog.
Yeah.
So that's what we selected: 3-phase voltage, 3-phase current, and the binary inputs, which is the trip. So of course, you see potential free, it means wet contact. So if you leave that activated, it will not give you some trip time because it requires voltage. So normally you have to remove that. That one is it's already free. So that's if you want wet contact, that one is you need to untick that one. Why my
potential freeze?
Yeah, on my software is in the other way around. if I untick that one.
So
it's gone. But anyway, that one is potential free anyway.
Sorry, Francis. Can you just untick that again? Francis wanted to check.
So yeah, if you untick that one, it means that it's no need for you to disconnect because if your relay test set sends some kind of voltage on the threshold, that's the time you stop the time. But you can assign anyway. You can change that one there.
So how does that threshold and range, nominal range, works? Like, can you give me an example? Let's say
it should be within that window. Like for example, we have a trip contact that sometimes if you measure, there's some 24 volts DC over there. So you have to lower this to 24. Is it?
24.
On the nominal range, that's your control voltage. So let's say the control voltage on your control circuit is, let's say for example, 24 volts.
Yeah.
So you can put 24 volts on nominal range, and the threshold will automatically computed.
There you go.
Really?
Yeah. So it's another way around.
Yes.
Yeah.
Yes. So if you set up first, let's say when you're doing your hardwire, you will see those control there. Let's say 110, 200, or normally it's 24 volts. So you just type that one there if you want to use a wet contact.
So when to use this? Sometimes, sometimes it's hard sometimes for us to, depends on the requirements of the client. If we are not allowed to switch off those control circuit and there is a voltage flowing on the contact to the relay, so it means you are unable to do dry contact.
Yep.
So you use this, you measure the voltage there, you put the threshold there. So once that 24 volts flow to your contact, your Omicron, it will stop the time. That's the requirements. Wet contact. That's a special scenario, but if you get used to it, you can do it. You know.
But don't focus first on wet because that's a little bit tricky
Yeah.
when you're doing connection. So focus first on dry.
Yeah.
Dry.
If you are confident enough to do wet contact, do it. Yeah.
Yeah.
Oh, they was try to make it dry, isn't it? Something like that.
I was about to
Ask
ask.
them to.
Yes.
Yeah.
I was about to ask the same question. So then, how do you connect? So when you say wet contact, so on your contact there's an existing voltage.
Yes.
So you will connect your test equipment parallel to that.
No. Not parallel.
Okay.
So that's why I'm saying this is a little bit tricky.
So it's like we gotta pull out the other one. Yeah, it's like a series switch, isn't it?
It depends on because we have two situation on the control. The control sometimes is the negative of the DC supply is solidly ground and earthed,
Yeah.
and the other one is unearthed.
Yeah.
So how we can put this in a easy explanation. So the switch of the line. Let's say our control voltage is solidly ground.
Yeah.
So one of your remember the symbol of switch, right? Like
Yeah.
Sure, yeah.
the switch is like
This one, yeah.
the on there. So what will happen there is this one has a positive supply, right?
Mhm.
Yes.
And this one, if the relay is healthy, so the contact will isolate the supply. So this one is free from supply.
Mm.
So what in the system is the control system is earthed. So you can just put your one leads here
And to earth.
and to earth.
Okay.
It means if you measure this E2, normally we measure that E2 to
Yeah.
earth. If I can get some voltage there, since that one is open, so I get that voltage there.
Yeah.
So if I measure F2 to earth, 0 because the contact is open.
Yeah.
So that 0 is alright for us to disconnect that because it's 0. Then we put our leads there from Omicron and the other leads to sense to the earth. Once the relay trip, that one will close.
And then
You will have voltage flowing to your Omicron.
Omicron.
Yeah.
Which is on.
Yes.
Then it will stop the time.
Yeah.
So again, Jonelle is saying it's a little bit tricky, but if you are really good in analyzing controls and everything, then you go that way. No need for you to isolate everything, but it's much better to do dry.
So do you disconnect on E? Is it F2?
F2.
You
F2.
disconnect on your F2.
Yeah, it
That's
depends.
when you put in your.
It depends which one is feed from.
Yeah.
It could be here, and that one could be
Yeah,
no.
sometimes
It depends.
other way around.
Yeah, so you have to.
So when you say feed from, that means you change the positive connection to the contact.
Yeah.
So let's say in our scenario here, E2 is my positive,
Yep.
and F2 I'm not getting anything because it's open contact at the moment.
Yeah.
Correct.
So what I'll do is I'll put my Omicron contact connections.
The
one
positive
on-
one there.
Positive one on
F2.
F2.
F2. And then the other one.
Other one goes to on
Earth.
Earth.
Without any disconnection.
I don't okay.
Yeah.
Without in disconnection, if you don't want to disconnect, because the client doesn't want to isolate the control.
Okay. So even we need to leave that F2 as well.
You
Yes. Yeah.
can. You
Okay.
can.
So you just squeeze in your lead on F2.
Yeah.
Yeah.
Okay.
You can.
So lose
That's
it.
wet contact.
All right. Because there's still voltage there.
But if that one is the control system is solidly ground or earthed, the negative of the DC is earthed. How about the DC, the negative of the control system is not earthed? So what will be your reference now?
You find the reference now.
The neutral.
Yeah, neutral.
Any neutral on the control can be
So another question. How do you know if it's neutral or if it's a common ground?
It's easy. So let's say you have a multimeter.
Yep.
I put the multimeter here to Earth, and if you don't have any voltage there, so it means it's not Earth. The control system is not earthed. But if you put your multimeter in here to Earth and you get half of the voltage, it means it's earthed. Okay?
Okay, so let's say there is no half of the voltage, that means you need to find neutral.
Neutral.
Yeah.
So, but don't focus on that first. We do the basic.
Yeah, basic one. It's a little bit advanced, but it's a good question.
No, just what I want to know is because I always get tricked in that scenario. I would definitely prefer to do wet contact. Dry first and then
Right, right.
Just
This is special one if it's hard, client being hard,
Yeah.
and don't want to isolate their controls, blah blah blah.
So let's say in that scenario, if you don't remove F2, you can and there's still trip going to this somewhere. So isn't it going to trip something? Let's say if that trip connection is going to intertrip or somewhere.
It's better to
It's
isolate.
better
So this
That's why it's better to do dry
To do
because
dry.
you isolate that thing. If you leave that connected, of course the circuit is the trigger. We don't know. Trigger different signals.
So in this scenario, we can also do this, even though we have another trick is, you can do this as a wet contact, dry contact, as long as you remove one leg of the wire.
Yeah. Exactly.
Because the principle of wet contact is a loop going back to supply. So if you remove this one, so you open the loop.
Yeah.
You break the circuits. So that by that time, so to make safe, especially on 369 relay, to save time, just remove one leg instead of removing both. So you just remove one, let's say in this case F2, remove F2 and then connect your leads there, and the other leads should be on the E2. So yeah, so to save time, because in doing the scenario on sites, like they only give you 1 hour, 2 hours. So
And also they are breaking the loop, so they are not having any signal to
sorry, when you remove the F2 connection, do you mean that will become a dry contact?
Because there's no return to ground.
Return connects, okay. So basically we're just removing the return.
Yeah. So you have so many options. Sometimes it's annoying when you just rack up there and the client will ask you how long. You haven't seen the schematic, you haven't seen the settings, how many protection is debated, and sometimes you need to cool down yourself. They thought that testing this kind of job is easy, but you need to analyze everything to do it properly. Yeah.
that's why it's in doing relay testing, you must have you are good in reading schematic drawings for control wiring, because bench testing, you can do it because there's no any external connection, but doing it on actual scenario like VHP or Rio Tinto, there will be an external wire now, so that's a different scenario.
So, so if we isolate the control power, then it means that we are using the dry contacts.
Yes.
Okay.
Yeah. But good question. But sometimes you still need to disconnect one of the wire, because what will happen there is sometimes it's go to a coil, like they call it a auxiliary relay. Because the reason for that is, especially on a big breaker, they use a auxiliary relay to handle the inrush current of the coil. Because sometimes the
capacity
contact here is not rated for that particular inrush current. So they use a sacrificial relay. Instead of damaging the whole protection relay, they use another auxiliary.
So is all the testing that we do in the bench are all dry contact, isn't it?
Yeah.
Yes.
Direct contact. So that's the difference between bench testing and in the real world.
The
So,
real world.
yeah. In the real world, you have things to consider, like intertrip and everything, connections and everything. So if you never consider those information, looks like you're doing bench testing, but it will affect other
Other system.
as well.
Yeah.
So that's the difference in bench testing and the actual one.
That's why, as per always, Francis mentioned, the best material you have on site is the drawing. Yeah.
So for those trip contacts, so you mean that the best way is to remove the connections from E2 and F2, then directly put your connections from the Omicron.
Not all
Not
the
really,
time.
not all the
Depends
time.
on the situation.
Yeah.
That's why I'm saying it's very tricky. which setup you want to do? Dry or wet?
And is there like intertrip if we just remove the control to the relay, control power to the relay? Is there intertrip for those things also?
It depends on the relay. Like for example, you see that auxiliary relay that normally mounted besides the relay, the one that we. You have to also very careful on that one. If you have normally close contact there,
It's gone.
and if you pull that off without considering where that normally close contact went, it means if you remove that, that contact will open. It will trigger trip upstream. Normally, the intertrip is from downstream to upstream. So you have to not only this, you have to check the schematic.
Schematic.
If no schematic, go to that specific model. Look at which terminal is existingly have a wiring connection at the back.
Yes.
If all normally open, when you pull that out, still normally open. But if that contact is normally closed and you pull that out, that auxiliary relay, that contact normally closed will become normally open. It will trigger other stuff out there.
So it's not straightforward. Yeah. It's like you need to analyze using your imagination.
Yeah. That's why we are good at imagination.
That's why we study imaginary numbers, remember? University?
Yeah. So anyway, I'll remove that one.
Yeah.
We go potential free.
Yeah.
Of course, this one, I can change this probably to, where's the trip? If you assign that as a trip signal, then put the trip.
Yeah.
If you assign this probably alarms or whatever, or auxiliary one, and for example, this one is auxiliary 2. So you put that one there. And of course, terminal connection. So terminal connection of trip, you go back to the manual. E1 and F1, E2 and F2.
Yes.
So you put that one there. E2, F2. And auxiliary 1, where is that? Manual. E3, F3. Is that auxiliary 1?
E4, F4.
Auxiliary 3.
We'll go auxiliary 3. Yeah.
E4, F4.
Auxiliary 3.
Yeah, in doing this, you will be, this is your another checklist for you to ensure that your wiring is correct.
Your wiring is correct.
Even on the analog inputs, you can also rename that, but we don't have time.
So sometimes we just run it without putting the proper address label. But it's good to do that one because you make sure that you connect it in the right terminal.
Yeah.
Like for example, this one, you never pick up the normally closed. There's a common of F4. So if you're expecting a close contact, you put it in the normally open contact here of E4, F4.
Correct, yeah.
So E4, F4. So we can put that one there. E4, F4. What was the another one?
F5.
F5, F6. E5. 6. So I think there you go. Oops. Click the wrong one. I think that's it.
And then click apply.
Apply. Outputs, no need for us to do that one. Analog is fine, I've never used that one. So I think all good for that. So hardware is okay. So what's the next one is M, which is stands for module. So Ohm's law is object, stacker, H is hardware. You put this one here. The module is, we're looking at overcurrent. Yeah. Hang on, we'll do the metering first, isn't it?
Yeah.
So,
Normally I use quick CMC on metering. It depends on you how you.
yeah, so that one. So if you put that, change that. Like for example, metering test.
I think that's a good practice before you start your testing.
Yeah. So metering test, you see that one there. So like for example, if you want to check now 63.5 equal, and this one here. So if you have 0.7, I think it won't trip on half of the CT secondary equal magnitudes. So say that one there. So it means that if you inject, if you expect display on the relay, if you inject half of 1 amp secondary, since you have 150 is to amp, you expect 75 amps display.
75 amps.
That's half of the 150. So you know now that you have the right CT ratio, and you have that one there. Then you run.
So how do you verify phases if you put everything equal?
Come again.
How do you verify the right phases if you put all the magnitudes equal?
So you can also change this one. It's part of the process. Like for example, you put 250, yeah, and then smaller one 150. It's up to you.
And also you can verify that. The good question as well.
Yeah.
You can verify that using your power formula. So the power formula will check if the connection is correct.
The power formula.
Yeah. You know,
Okay, yeah.
root 3 or 3 times of B current, and then current times the power factor. Obviously, the power factor there will be unity because the current and voltage, as you can see on the diagram there, is in phase.
So we see that one here.
So that one will also check your connection.
So yeah, on this one you can do everything I think on the quick CMC. So if magnitude, you're talking about the magnitude of current, and you can put some kind of ramping here, and then you ramp it up and down. Or if you go for angle, you can rotate that one until it trips. This module is handy as well.
Quick CMC, yeah?
Yeah. So
you can do testing in time also.
yeah.
You come to my best friend already, you can see.
So anyway, that's the metering. We'll save that one probably. Always remember to save.
Yeah.
We go to the desktop. I think.
That's the most important thing to do. Save your test results. Yeah.
Yeah. So another one after you do that one, so you have to add module again. Overcurrent. So there you go, overcurrent. So I can go probably line 1, line 2, line 3, but anyway, we'll go basic one. Basic one. So double click that one. So if you add this thing here relative to, you have, this is the one that we created earlier. Remember? Phase overcurrents, stage 1.
Yeah.
and stage 2. So at the moment we have to pick this. Okay, so because normally we do line 1, line 2 for the reason that we have discussed to avoid tripping the earth fault. So I will do probably basic on that one. So if I add that one, let's say the multiplying factor will be times 2. Means times 2 of your setting. So it will show you 0.7 times 2, you have 1.4. So you have the expected time of
65 seconds.
You didn't change the factor yet. Yeah. And under the factor, just put 2, please.
why it never changed. 2.
Enter.
Yeah, there you go. So you have 106 expected time. So normally we do that way. Like for example, if you want to test that partner, you have to add another one. Right. Now we go back here. We have to add one, and we have to line 2, 3, and so on, and add another one, 3 and 1. So that's how you do it sometimes. So times 2. But anyway, we will do it 3 phase just in case, just to shorten those, because that one will come with a long list of tests. You know. So anyway, so that's how you can see it. It's times 2 is here. But anyway, I think I have to do this one 3, and this one as well is 3. 3 phase, so that we can shorten the number of, and then the test point, you know. And I'll do this, that's 2. Normally 2, 4, 6. This one is, we'll do 4. Change that one. You see the dot here?
Still in the curve.
Yeah. That's the expected one. And then we do 6. So there you go. And of course, this one here, we can add another one, another stage. I think I have to remove this.
Yeah, just click remove. Yeah.
So, because this is instantaneous, isn't it? So I need to use this one, I think. 1 something. 1.2 something. Yeah. So 5.37 times 1.2, you have that one there.
Yeah. So you are above the threshold.
Yeah, the threshold.
Yeah.
Because if you look at the setting that we have, I put 1 there, give you 5.37. So it's definitely on that line. So that's the setting that we did there. So put 1.2 is a little bit over, so that you can see the trip over there. And of course, we have to add another one, which is the stage 2. We pick the stage 2, which is, yeah, there you go, it's already there. So 20, that's 1.2, you have that one there. So we see there the expected time is there. So you have now your dots.
I just want to share what I always do there. So normally on the third point here, so I use reference the first stage of instantaneous and then less 5%.
Yep.
So that I can show that the dot will be somewhere here, close to the edge.
So
and also I'm doing that also in here, which is I use the reference of first stage of instantaneous and I add 5%
Yeah.
to that here.
So you can see that the transition from the curve going to the instantaneous strip.
Yeah. But it's up to you.
Yes.
All the tests that you're doing is correct.
So on the factor there, you put 1.05
Yes.
Yeah. So
instead of 1.2.
if you change this 1.05 here, So 1.05. So you are 5% above.
Yeah.
There you go. And then if you go another one, let's say I have to add another one. Move above.
Drag it.
Okay.
Then
It won't, I think. Normally there is some kind of remove. Anyway, I'll add another one. Let's say that one
The
is
right hand side move up.
0.95.
This one here move up.
There you go. Yeah. I'm looking at move up here, but it's there.
Yeah.
So, okay. 0.95, you can see that one there. So move up. Yeah, there you go. So you have plus or minus 5%.
But it depends on you.
It's up to you.
Yeah, it's up to you. But yeah,
What is the standard?
as long as you have 3 points on the IDMT, that's normally required by the client.
3 points and then 1 point on the definite time.
Yeah.
Okay.
So in this testing, you test the curve, you test the instantaneous. If you run that one, it will run through all the points.
Do you need to have those 2 points close to where it's transitioning? Do you need to still have that other one, those 3 points?
No.
Did that one there? Do you still need to have that one or?
No, if you want to get total 3 on that, it's okay.
And the fourth,
This one here?
No, the one, that one, that one there.
6 times.
so you can remove that one as well.
You can remove it?
Yeah.
Since the other one is
Yes.
This one.
Because what I trying to prove there is
the transition.
the transition between the IDMT to instantaneous processing.
So yeah, I think that's the test plan that we have.
And in this setup as well, you don't need to disable because I saw some relay tester.
Nick.
They disable. Let's say they want to disable this one just to do 246.
Isolate.
Yeah, no need to
Yeah,
do
you
that.
don't need to disable.
If you're defeating the very purpose of the curve.
Yeah.
Are you listening, Nick? Yeah, good.
We're here to learn anyway. So
No, I'm just no
So, yeah.
Just kidding.
so you have
Yes,
that one and save.
You'll be accessed.
Okay, pick up. So normally, I think this overcurrent, I will change the name to overcurrent
Pick up.
and instantaneous because it's combination of two over there. So we do pick up, add another module, and since we do pick up, it depends. You can do quick CMC as well, and do that on the curve one. But that one is quick. We've done the quick CMC. So probably we'll go some kind of pulse ramp. What is pulse ramp? Pulse ramping.
Yeah.
For the short circuit. So let's say rename this. First stage. Pick up.
So pulse ramping is good when you're doing instantaneous pickup.
Yeah, because it won't. It prevents you in cooking the contacts. So yeah, so you have on our setting. I think the setting is, let's say, 5.37. So you have to start here.
Below the IDMT.
Let's say 5. Oops. Let's say 5.
No, that's your reset time. So it should be less than the IDMT, which is
Yeah.
Let's say below 0.7.
So 0.5. Equal magnitudes. Okay. And this one should be around 5.
Yeah.
So you have your pre-fault there, and you assign your pre-fault time, say 2 seconds.
Yeah.
So you say 2 seconds, and that 2 seconds will run at that scenario. So it will stabilize the relay. The relay will see that everything is normal. And if the relay see that it's normal, no trip, and then the first fault is this, it go 5, but our pickup is 5.37, so I'll go probably 6.
Yeah.
So I'll go at 2, but it's negative. It should not be negative, eh? Is that negative?
No, positive,
But positive.
because initially it was 1.
Yeah. So it means that you have to, that one is the delta, the increase,
The increment.
the increment. So you have a reset time, let's say this is too quick. So let's say 500 milliseconds.
That would be
Yeah. So, and the fault time, it means you have to exceed.
The pickup.
So 45
5.
milliseconds. Sometimes they put less than that, it won't trip, but you have to put 0.5 probably will do, or 0.7 probably, because 0.45. So this one will be, your fault time is 0.75, let's say.
Because
So-
what happened is there's a process inside the relay.
Yeah.
Let's look if this is within the threshold or still not in the threshold.
Yeah.
Yeah.
So in every 75 milliseconds, it will stay there on that level with an increment of, after that 5 milliseconds, it will go to rest to avoid cooking the contact. Rest at 500 milliseconds and up again with additional 200 milliamps. Slowly increase. So you can see the number of steps here until it reaches 6 amps. And the time duration is 9.5 seconds. But it won't reach 6 amps if your relay will work properly, because you have the target of, you have to put that one there, 5.37. That's your expected one. And again, the tolerance. So it depends if you want the specific current. Depend on, this one will come from the manual anyway.
Yeah.
So if you go, let's say, probably 35%, because it's short circuit anyway.
Yeah.
Say 35%. Plus or minus of this, and the actual trip will be assessed based on this tolerance compared to this one.
I think we need to reduce the delta current
It's too.
because
Oh yeah, it's too big.
so what I'm saying.
So maybe 20 milliamps or
50 milliamps probably.
50, yeah, probably.
And then with this one, you see, will increase.
Increases a lot.
21.
5 to 5.5.
Yeah. So yeah, that's the way to do it when you're injecting higher magnitude.
So
It will take 28.25 seconds to finish the whole test.
You have to finish
To finish
this.
that.
that's the maximum
Maximum
duration
interval.
from 5 to 6 amps.
Okay.
It doesn't.
It doesn't mean it will finish 28 seconds.
Yep.
So it will end before 28 seconds.
Once it trip.
Once it's tripped, yes.
So is the 50 millisecond, the reset time and the fault time, what guides those two numbers? Because you need to, obviously for you to arrive at those numbers, you are aware that obviously this won't cook my things if I keep it at those numbers. So how do you decide?
So normally you use that here. For the maximum one should be a little bit higher than this.
Just slightly higher than that.
Yeah, and then of course this 500 milliseconds probably enough for the algorithm of the relay to reset everything there to normalize. You can go more of that, but it will take longer as well. So it's up to you.
Yeah. Okay.
Yeah.
And again, the reason for the hold time to be higher than the threshold time, because as Francis explained earlier, there will be a process inside the relay. So that process needs to be finished first before the relay will trigger any output.
Yeah. All right. Yeah.
And we are injecting this current on all the three phases, isn't it?
For now, yeah. But
we
normally,
can do it just in one phase.
Two phases.
yeah. If you don't have, if you don't have the earth fault, you can do that one phase. But if you have earth fault, then you have to do it by two to avoid those other. Because if you do it on that way, and then you are not tripping on the instantaneous, you're tripping on the earth fault, then you get the wrong time.
Oh, yes.
Then you have to identify, hang on, what's happening.
Yeah.
You have to step back and analyze
Yeah.
what's happening.
Going back to the principles that we learned earlier. Yeah.
Again, this training is not make you an expert, but it's up to you how to apply this to be an expert. It will help you to develop where to start.
Yes.
You know. So yeah, that one can be done in combination. Like for example, if you want this line 1, line 2 only, so you zero the one, and then you go to the combination of line 2, line 3 later on, blah blah blah. You can file up and populate more test module. But for now, for training purposes, we have to make test module as small as possible. Maybe, yeah.
I think in signal there should be 3 phase. Yeah.
Yeah. So this one should be 3 phase.
Yes.
Yeah.
Because if you only put one there,
Yeah.
means it will trip the ground.
Yep. So yeah, your expected feed from the relay should be from open to close,
Yeah.
which is dry contact. Open to close. Okay. Binary outputs again. Whenever you use the one. So immediately, yes. Assessment, delay of assessment. Yeah, those things. You can put that one as well.
Yeah.
Yeah, so you have the pick up and trip. So I think that's most of the thing. And another one, simple one, is to do the timing as well. If you want to separate the timing from this, you can add probably state sequencer.
Yeah.
Where is the state sequencer? This one here?
Yep.
Which is handy. I think it can test most of the.
Okay.
Like for example, if I do this instantaneous, it can also do the job. If you want to separate them, like line 1, line 2, this one. So if I double click the one, it gives you the picture of this thing. So the state 1, you can put probably the normal condition, like the free pod. Let's say 0.5. Because you have a pickup of 0.75, so equal magnitude, and you set the time there, like say you expect no trip at 3 seconds, and then you add another state. States after. So you put your fault there, like times 2. Times 2, like you can change this, I think. Times 2 of 2 times
I double versus.
yeah, I double. Yeah. So if that one is I double, you expect to have this.
10 point something or 13.
Yeah. So let's say 5.37. I would say 11. 11. Yeah. 11 amps. Equal magnitudes. So expected time is 0.45 minutes, so I put probably 1 second. So when you run that one, of course you have to identify this one as well. Binary output, the trigger one. Trigger means if you allow timeout for this, it means doesn't matter if the relay or the trip, it will continue injecting 3 seconds. But if you put binary input trigger and remove this one, if there's some trip coming from the relay, state 1 will initiate trip. You will not proceed to the next transition. And also you have to assign this one here. This is the one that we assign. You have to pick which one will trigger the stop. Or and, but anyway, we're not gonna go there. So yeah, general. So that's the first stage. So if you go to the second stage, you have to decide again, not timeout, because you have to do binary trip because it's relying on the feed from the relay. So again, you have to pick this one here. So that is your first stage and second stage. And you have to name this. Like for example, trip. You have to pick which one. This one. Start state. You have to start here. And stop. You have to stop here as well. If you don't want to add another state, you can stop here if you want to add. And the nominal time.
450 milliseconds.
Yeah, 50 milliseconds. And the deviation, of course, you have to put some kind of, let's say 30 milliseconds. 30 milliseconds. So wants to do some kind of number thing. 0.03. Yeah, so 0.03. So this one will determine your pass or fail. So the software, you allow the software to judge if it is pass or fail.
Any question regarding this?
I'm very confused there. Ignore before that. Wasn't that supposed to be step one?
So ignore
before step one, right?
before this is this.
Now before the second stage.
Before the second.
Yeah.
Anything happen before the
Yeah.
in the first
Or ignore before that.
Before this, it ignores this. It means the time will start on this, which is this.
And end on that one. Okay.
Yeah, and stop on this. But if you want to add another one,
No, I got the point.
I think the stop one should be the trigger contact. The trigger zero.
Oh yeah. Stop one will be 0 to 1. Yeah. So,
So, Francis, just wanted to know about the table there. It says trip, and the state is 1. If you press it again,
which one?
yeah.
This one?
So yeah, if you press again, so
0.
that's 0. So that's the state that we're looking for, is it? So let's say if our trip contact is normally closed,
And you're expecting a 0 inputs, you put it that way. Because 0 or 1.
so 0 or 1, is it like a logic or what is that?
It means that 1 is normally closed. You're expecting normally closed
So that's what I'm expecting.
from the relay.
From the relay.
Once it operate after that, or
Once the relay operates, it'll give you one signal if you're expecting normally closed from the relay. Like for example,
okay.
this one here, it's normally open. It's currently in 0 position.
Okay.
Yeah, 0. Yeah.
Okay.
Zero.
Once the port activate, it will give signal close, which is go to 1
Okay.
signal.
So we'll put it as 1. As 1.
So you put that 1. You're expecting 1.
1. Okay. So that's the reason about got it.
Yeah. So you see here,
So
0
0
to 1. It is open to close.
From goes to 0 to 1.
And if we keep it as X, that means
You're not gonna expect anything.
okay.
Yeah.
So this is for timing, yeah? You do the timing.
Yeah. Timing to measure the speed of the response of the relay based on the setting.
There was another test then also for timing, because
Settings is for 0.
Yeah. So that's why you can use the
You can ask.
quick CMC
Yeah.
on that one.
Relay.
So yeah, that's most of the basic one, and it's up to you to, because sometimes testing is up in how you understand the behavior of the relay.
How you would attack.
Yeah, how would you start the testing for you to be satisfied that this is okay? So number one is you have the documents, the drawing, and this one here. You can see if you connected to those terminals properly, the current, the voltage. Of course, you have there the ground fault and REF. So you make sure that that one is connected properly as well, because some of the relay have a separate signal and some of them are zero sequence. So you have to look at those things. Look at this thing as well. Which one is wired or not wired? So you have all those documents: the setting, the hardwire, the schematic drawing. So I think that's it. I think for now, I think if everybody can help to set up the 750 over there and the Omicron, and we will guide you guys. I suggest you have your own laptop, and once you talk to the relay, one of you can talk to the relay and then get, as a practice, get all of this on your notes, and then create your own test plan.
Yeah.
And then one of you, as a training, check whose test plan is working properly and how you create it. You have to do some kind of workshop for you guys to, to navigate the software. Any question? Yeah.
So when you're doing pickup, you trying to do your pickup value. You're trying to get your pickup value, and your trip is normally what you put as your feedback on your binary. So when you're doing your pickup, how do you sort of? I know people do it manually, but you could also do it.
You can do manually.
Like you just run it. And
Yeah, this is the one.
So this is for instantaneous pickup.
Yeah.
But instantaneous will trip
Yeah, of course.
instantly.
Yeah.
But when you're doing it on the IDMT, yes. How do you do it like in this sort of setup?
There's a different in the relay. The relay also, you can assign some pickup of this. Some other relay have capable to assign the pickup.
Yeah.
So you put that signal on that specific protection. If you want to, like for example, pick up of your IDMT, your curve, the pickup of 0.75. You pick one of that, assign that as a pickup with a specific specific protection, and you run automatic like this. You can use this one. But if not, you can see some kind of LED. If it's pickup or not, then you can manually ramp it using Quick CMC. And they call this manual assessment, that you hit the stop and the pickup. You can see the pickup as well. The stop, you can get that one manual as well.
Yes. For double is manual assessment.
Yeah.
In here is key press.
Yeah, key press. Yeah.
But in this GE 750, they provide a LED.
Yeah.
LED that you monitor that LED, and then once you see the LED is lit
Lift
up,
up.
Yeah.
press
it. That's your
That's your
pickup.
pickup.
Okay. So you ramp it up and then you record using the kick,
Yeah, like
your pickup kick.
where's the one?
have an option for key press.
Key press. Yeah. Let's use this as an example in a way. So you have to manually ramp it up
Yeah.
until you see that the LED of the front face of the relay is
Yeah.
blinking like that,
Yeah.
and you key press. Once you press that one, then you see the magnitude here, and that's your pickup.
Yeah.
Okay.
There's so many ways.
Where do you press again on the relay?
No,
on the
On the
software.
software.
On the software, you click by mouse or you enter some keypad, and then it will stop. And you stop on the specific magnitude that you see that LED like blinking on the relay. So that's another one. That's a quicker one, I think. And the other one is you have to assign specific contact for the specific pickup of that IDMT curve.
Yeah.
Yeah, so that's the overview of the test plan creation. So I would suggest that, I think we can go to the workshop. It's 12 o'clock anyway, so probably set up that Omicron, whoever the leads, set up that with the 750, and probably some of the people can share on the laptop to create the test plan based on the existing settings. So it's up to you. You activate the voltage or frequency. It's up to you. But it's the same. You have to ramp it up the frequency up and down based on the frequency. Like if you pick this one here. So no, not that one. So sometimes you can pick that.
On the quantity.
Yeah, here. So frequency. So it means that that one will run as ramp up, ramp down. So it's flexible. Or you can do all of them. Yeah,
All outputs.
that one there.
Yeah.
So it means you are looking at ramping up the frequency.
So when you do all outputs, that means voltage and current all together.
For the frequency.
For the frequency.
Yeah.
Okay.
So like for that one is 48.8, I think. So from 50, let's say you have to do 0.5 something. Let's say put anything negative. So that's it. Yeah, that's just an example anyway. So anyway, I think that's all for the presentation, and we have to go to our hands-on training. Yeah. So we need you guys to set up the Omicron 750, and I don't know if everybody has a software of Test Universe. Once you communicate, one of you communicate, get all the reading, and then create your own test plan, and one by one plug your laptop and then run the test. Okay? All good?
You could please give us the recording.
Let us finish.
So,
And the testing.
stop. Nikuns, stop here.
Yes.